This particular tutorial will be on how to calculate drainage density. So first of all, you will load DEM and then you will go to geoprocessing toolbox. If you're not able to find your geoprocessing toolbox in ArcGIS Pro, you will click on Analyst. Then you will click on Tools and then your geoprocessing will appear out here. So you click on geoprocessing and go to Special Analysis under Special Analyst tool under Toolbox. And then you will go to Hydrology, and then first of all you will run FieldDem. So if you look at the information of this one, the input raster represents a continuous surface. Here there would be some places where there will be no data, or there will be some places with depressions. So this particular tool will recover those areas where there are no data or it is under depression. Not under depression, it is a depression. If it is a depression, so here you will load your DEM and then you will just run. So here you will have your FieldDem. Then you have to calculate the flow direction. So flow direction is a special analyst tool. Create a raster of flow direction for direction from each sail to its downslope neighbor or neighbors using D8, that is deterministic gate multiple flow direction MFD and D infinity DI and F methods. So which is represented out here in this elevations raster, and then the flow direction using the sail. So your input surface raster will be FieldDem, and the name it as maybe flow direction. And then if you want to save this particular flow direction raster permanently, then you will select the folder where you want to save. Otherwise you can keep it temporary. And then your flow direction type, there are around three methods, that is MFD, DI, NF, and then D8. So you will select D8 deterministic 8 and then you will run. Then you will have flow direction out here. Now you have to calculate flow accumulation. So if you go here and look at the information about flow accumulation or description of flow accumulation creates a raster of accumulated flow into each sail. A weight factor can optionally be applied. So flow direction equals to flow accumulation, which is represented by this particular image or sail. So your flow direction raster, you select your flow direction raster, and then input weight raster you can select or keep it optional, and then output data type should be float. There are again 3 to 4 options, and then input flow direction type, it is deterministic 8 or D8, and then you can run. So you will be able to get your flow accumulation out here with a white line which shows a major tributaries in this particular river basin or watershed. Then once you are done with that, then you have to derive the raster stream. So you look for raster calculator. Then here you have to derive the stream raster from flow accumulation. So flow accumulation, then maybe 100, then name it as maybe a stream raster or something else which is convenient for you, and then run. Then you will get the stream raster. So here are the streams in the form of pixel or in grid form or in raster image or raster format. Now you have to calculate the stream order or Staller order. So go to stream order and then stream raster. You will select your stream raster, then input flow direction. So here you will select flow direction, and then the method should be installer. So here are two methods, that is stream, shreve stream, and then installer, strall installer. So you will select installer and then run. Now you will have the installer order streams, which is represented in different color out here. So different color out here represents different installer order. Now you have to convert this stream order raster into the polylines or the multi-line or lines. So you will select stream to raster, stream to feature tool. So here converts a raster representing a line network to features representing the linear network. So here your input will be your stream order raster. You have to input your flow direction and then you can run. So it will convert your grid or stream rasters into polylines, which is represented this way. So here these are the vector lines, okay, which you can see for, let's say, Amochu. Now to calculate the drainage density of this particular streams or this drainage, you will go to density, and then here you have options. Example, calculate kernel density ratio, then you have kernel density, okay, line density, point density, and then space time kernel density. So you will select line density and then your input polyline feature, that is stream order vector lines that you have converted from stream rasters. So population field, either keep it null, none, or default field, or you can select from here whichever you want to, whichever field you want to select in order to run a or generate a density map. Then output raster, name it as maybe drainage density. Out here let's name it as drainage density dd, and then area unit. So you have several options, so you can select meter, centimeter, square kilometer, okay, whatever, and then you can run. So once you run your line density tool using your stream order polylines, it appears like these, meaning, so here the blue, dark blue represents the high density, and then rest of the maybe palish blue, I should describe it as, represents density, a low density. So it ranges from 0.001 to 4.921.